Let me show you the steps of solving that stoichiometry. It's very, very easy. Trust me. Just stick to these 4 steps of solving stoichiometry and follow it accordingly, and you will always get your answer easily. The first step is what? To balance the equation. You write out the equation of the reaction, then you balance it. The second step is what? To convert mass to mole. That's the second step of solving stoichiometry. You convert mass to mole, depending on what you are looking for or what you are asked to find. After that, the third is what? Use mole ratio from that reaction, from that chemical equation that you balance. Use mole ratio from the balance equation to get mole. Now that ratio wey be say you get, now you go take get your mole. Alright? From that ratio, use it to get mole. That's why it's very, very important to balance the equation, to write out the equation and balance it. Alright? Then also, the final one, you convert back to mass. You convert back to what? Mass to get your answer. Remember, stoichiometry most of the time is asking you about molar mass, or it is either asking you about molar mass or it's asking you about mass. That's all about stoichiometry. The mole concept, the question there is usually they're asking you mole. What is the mole of this required to do this, and so on and so forth. So today we are looking at stoichiometry using mass. All right. This is my WhatsApp number in case if you need any material. If you need the material for the most repeated question by Jamb, send me a DM. Connect with me on WhatsApp. You want me to coach you for the Jamb UTME exam? Send me a DM. All right. Let's quickly start. The Jamb must repeat question 1, another stoichiometry using mass. It reads, calculate the mass of hydrochloric acid needed for a complete reaction with 43.5 gram of manganese 4 oxide. All these are the molar masses of all the elements. All right. These are the options provided, represented in what? In gram. All right. Remember, mass for chemistry now gram, they measure gram for chemistry. But for physics now kilogram. That's the standard. But in chemistry, it's quite different. Okay. In stoichiometry, the first thing to do, once they give you any stoichiometry question, okay, asking you to calculate the mass of this, the first thing to do, if you have any chemical reaction there, the first thing to do is what? To balance the chemical equation first. Let me just write it. In stoichiometry, balance equation first. Okay, balance equation first. That's the first thing to do. All right. So what do? They said the mass of hydrochloric acid needed to complete the reaction with 43.5 gram of manganese 4 oxide. That's the reaction is between hydrochloric acid and manganese 4 oxide. All right. So we have hydrochloric acid plus manganese 4 oxide. Manganese 4 oxide. Okay, to give us what? Complete. He said complete reaction. If you look at this place, you dey see everything wey dey here. Everything wey dey inside here go dey this side. All the elements wey dey here go dey this side for the reaction. So you react it together. So chlorine will react with manganese to give what? Manganese chloride or manganese dichloride. Okay. Chlorine and manganese. Okay. So plus what next can we get? What else can we get? We are going to get water. We are going to get water, H2O. What else can we get? Water, H2O. Okay. Complete reaction. You are also going to get chlorine. Okay. All right. So these are the constituents. What you are going to get, the product of the reaction. Okay. So if you want to balance this equation now, we have to balance the equation. Is not balanced. We have to balance the chemical equation. How many hydrogen and chlorine do we have here? We have just one. And here we have 1 chlorine. We have 2 chlorine molecules. Okay, that's 2. Okay. So what do we have to do? This one is 2, and this one is 2. That's we have 4. 2 molecules here, 2 molecules here. We have 4 chlorine molecules. So let's put 4 here. We don't balance chlorine with that. So we have 4 chlorine molecules here. We have 2 molecules here. We have 2 molecules here. That's 4, left side and the right side. What next? Hydrogen. Is hydrogen balanced? We have 4 hydrogen here. Here we have just 2 hydrogen here. What are we going to do here? We just add 2 here. So that's 2 times 2 will give us 4. How do we balance this one now? What do we balance this? Manganese. We have just 1 manganese here, and here we have 1 manganese to balance. Oxygen. We have 2 oxygen here. Here we have 1 oxygen, but 1 times 2, because this applies to everything here. 1 times 2 will give us what? 2 oxygen. So oxygen balanced. So what it means is that everything, the equation is now balanced. All right. So let's now write out the formula. First of all, what are we looking for? Calculate the mass. We are looking for mass of this needed. The formula of mass is equal to mole times molar mass, which is capital letter M. All right. What did they give us to solve? What did they give us make we solve this thing? They gave us the mass of HCl. They give us, now we look for mass of HCl. Okay, that's mass of hydrochloric acid. What is mass of manganese dioxide? Mass of manganese dioxide is equal to 43.5 grams. All right, so this is the mass of manganese dioxide. Which other thing they give us? They can't give us their molar masses, but I don't think they write molar mass for here. They don't already give us for here. We see them well. So that one a waste of time. All right. Since we are looking for mass, this is the formula we have to apply. Do we have the mole? The mole? We don't have the mole. But do we have the molar mass? Yes, we have the molar mass. We have the molar mass of HCl. We can easily calculate molar mass of HCl using this. All right? It's very easy. Very, very easy. Okay? So remember, we are talking about a complete reaction of this, okay, with manganese 4 oxide. Okay, a complete reaction. First of all, we have to find the molar mass of manganese dioxide. Okay? After that, after finding the molar mass of manganese dioxide, we now move straight to what? We move straight to finding the mole of manganese dioxide. All right? So the molar mass of manganese dioxide is equal to, what's the molar mass of manganese? 55 plus, what's the molar mass of oxygen? The next thing for them are oxygen. Remember, we go times am by 2 because we get 2 here. Molar mass of oxygen is 16. We'll come put bracket 16 times 2. Okay, so now this one will give us the molar mass of this thing. So equal to, we are now going to have 55. Okay, plus 16 times 2 now 32. This will give us 55 plus 32, 87 gram per mole. Okay, molar mass. All right, so the molar mass of manganese dioxide is 87. So let's put it, molar mass of manganese dioxide is equal to what? Is equal to 87 gram per mole. All right, so what's next? The next thing is to find the mole of manganese dioxide. Very easy. So the mole of manganese dioxide, mole is equal to, remember how to calculate mole. Mole is equal to mass over molar mass. Okay, so what is the mass? They give us mass. We get mass here, so we can solve. And we have the molar mass. So mole is equal to mass over molar mass. Okay, equal to, what is the mass of this manganese dioxide? The mass is 43.5 over molar mass. Molar mass is 87. Okay, if you divide it, we are now going to have mole of manganese dioxide is equal to what? Is equal to, when you divide this, it will give you 0.5 mole. All right, so this one is the mole of manganese dioxide. So since we now have, remember, we want to apply a formula. Okay, this particular formula. We have to look for the molar mass. All right, now we are looking for what? The mole. All right, so before we do that, we are going to need the ratio from the stoichiometry of the reaction, which is this, the ratio, what is required. So we needed 4 mole of hydrogen chloride, hydrochloric acid, to have a complete combustion, or to have a complete reaction with manganese 4 oxide to yield all these products. Okay. So 4 moles of hydrochloric acid react with what? 1 mole of manganese dioxide. So the ratio is 4:1. Okay, 4:1. This one is the stoichiometry ratio. So stoichiometry ratio 4:1. That's the stoichiometry ratio. All right. So the mole of this, now is the time to find the mole of HCl. Okay, that's hydrochloric acid. The mole of HCl is equal to, for us to get the mole of HCl, we are going to use, what is the quantity during the reaction? The ratio, stoichiometry ratio is 4 now. So is that 4 that we are going to use? It's now going to be equal to 4 times, what's the mole? What did we get when we divided the mole of manganese dioxide? We got 0.5. Okay, 0.5. So we have to times both moles. Okay, so we have 4 for HCl and we have 0.5 for manganese dioxide. So 0.5. Okay, so if you times it, is going to give us 2 moles. 2 moles. Okay, so both moles is 2 moles. Now let's now find the molar mass of HCl. Molar mass of HCl equal to calculate the molar mass of HCl, what is the molar mass of hydrogen? Hydrogen is 1. 1 plus, what is the molar mass of chlorine? 35.5. All right, so 35.5 plus 35.5, and that will give us what? It will give us equal to, we are going to be left with 36.5 gram per mole. Okay, so this one is the what? Molar mass of HCl equal to 36.5 grams per mole. All right, so what next are we doing? Since we have gotten molar mass of both of them, we have also gotten the masses of manganese dioxide. Now is the time to calculate the mass of HCl, which is the mass of hydrochloric acid. How do we calculate that? What's the formula for mass? Mass is equal to mole times what? Molar mass. All right, so mass is equal to what? Mole times molar mass. Okay, so our mass now will be equal to, what's the mole? 36 points. No, this one is the molar mass. Okay, the mole is what? What's the mole? We did the this one is the mole, 2. So 2 is the mole. So it's the same thing. If we do 2 times 36.5 or 36.5 times 2 are the same thing. Okay, 36.5 times 2, that will give us what? It will give us 73 grams. All right. Remember, we are looking for the mass of HCl, and that's this. So among the options, pick the correct option and drop it in the comment section. Now let's look at Jamb must repeat question 2 under stoichiometry. Okay, the question 2 here reads, the molar mass of CaCO3 is what? This is my mind now. Very cheap question. I already taught you how to solve molar mass, but let's solve. The formula of molar mass, no need for formula, I don't already teach you the procedure, but the formula of molar mass, to calculate molar mass, is equal to the summation of atomic mass. Okay, the summation of atomic mass times the number of atoms. Okay, for example, this CaCO3, CaCO3, all these are numbers of atoms. Calcium has only one number of atoms. Carbon has one number of atoms. Oxygen has 3. You can see. So that's it. So to calculate this molar mass, it will be summation of atomic mass. All this atomic mass, we go sum all of them together. We're going to get something like, the first atomic mass for calcium is what? 40. Plus, we are summing them. Okay. The second one is carbon and it's 12. Okay. Plus, what's the next? The next we have here is oxygen, 16. And you know that oxygen, look at it, times atoms. We have 3 atoms of oxygen. So we are going to times this atomic mass by the number of atoms. Okay, that's 16 times 2. Okay, so 16 times 2 will give you what? 32 plus 12 plus 40. If you solve this, you simplify this. This is going to give us molar mass of CaCO3 is equal to 100 gram per mole. So among the option, pick the correct option and drop it in the comment section so that I will believe you understood.